Hi everyone. In this video, I will present a data-driven analysis of Netflix mobile app user reviews using natural language processing and supervised machine learning. The initial question I'm trying to answer is, can Netflix use mobile app review text to identify dissatisfied users and understand the specific drivers of negative app experience? The business problem is that Netflix's mobile experience may be contributing to customer dissatisfaction and possible churn risk. Since many customers interact with Netflix through the mobile app, problems like crashes, loading errors, login issues, payment confusion, or poor usability can reduce the value of the subscription. To make this measurable, I translated the business problem into a supervised NLP classification problem. The goal is to use app review text and review metadata to predict whether a review reflects dissatisfaction. Since actual churn labels are not available, I use dissatisfaction as a proxy for potential churn risk. The dataset comes from Hugging Face's datasets. It is a Netflix Google Play Reviews dataset containing real user feedback about the Netflix mobile app. After loading it, the dataset contained 5,000 reviews and 15 columns. The most important column is content because it contains the actual review text written by users. This is the main unstructured text field used for NLP. The rating column is also important because it provides a structured signal of satisfaction or dissatisfaction, and I use it to create the target variable. Also use created at for time-based analysis, thumbs up count to understand which reviews other users found helpful, and app version fields like app version and review created version because negative reviews may sometimes be linked to a specific app update. This dataset is appropriate because it combines qualitative feedback through review text with quantitative rating data. However, it does not include actual churn, subscription plan, viewing behavior, or internal app performance logs. So the model should be interpreted as dissatisfaction detection rather than true churn prediction. Next, I cleaned and prepared the data. I standardized the column names, created a working text column called review text from content, converted the rating into a numeric score, and converted the review date into review underscore date. I also converted thumbs up count into a numeric field and filled missing helpfulness values with 0. Then I removed duplicate reviews where possible, removed empty review text, and kept only valid ratings from 1 to 5. This pre-processing is important because missing text, duplicate reviews, invalid ratings, or incorrect data types could distort the NLP analysis and model results. For text pre-processing, I created a clean version of the review text called clean text. The text cleaning converts reviews to lowercase, removes URLs, removes punctuation and unnecessary symbols, removes extra spaces, and removes common stop words. One important decision is that I keep negation words such as not, no, and cannot, because phrases like not working or cannot log in are very meaningful in app reviews. I also created review length features, including character length and word length. These help capture how detailed each review is. For the target variable, I created a sentiment group from the rating. Ratings of 1 and 2 are labeled as dissatisfied, rating 3 is treated as neutral, and ratings 4 and 5 are labeled as satisfied. For the binary model, I removed neutral reviews because they are ambiguous. The final model predicts the dissatisfied variable. Now, for the EDA, I first looked at the rating distribution to understand how reviews are spread across 1-star to 5-star ratings. Then I looked at the sentiment group distribution to compare dissatisfied, neutral, and satisfied reviews. After cleaning, the notebook keeps over 4,000 usable reviews for analysis, and the binary modeling dataset contains 4,008 reviews. The dissatisfied share is around 55.9%, which means the dataset contains a strong amount of negative feedback. The average rating is about 2.78, showing that dissatisfaction is a meaningful issue in this sample. These summary statistics are useful because they show that the dataset has enough dissatisfied and satisfied examples to support supervised classification. Next, I created business-readable complaint themes from the review text. The themes include streaming and buffering, crashes and bugs, login or account access, payment and subscription downloads, and offline viewing, UX and interface, and content availability. This is important because it turns raw text into categories that Netflix teams can act on. A negative review alone is useful, but a negative review connected to crashes, login issues, or payment problems is much more actionable. The theme analysis shows that several important issue categories appear frequently. For example, payment and subscription issues appear in 476 reviews, crashes and bugs appear in 459 reviews, login and account access appear in 334 reviews, and UX or interface issues appear in 277 reviews. While content availability is one of the major themes for complaints. This helps Netflix prioritize. Crashes and bugs would be most relevant for engineering teams, login issues for account support, payment complaints for billing teams, and interface complaints for product design teams. I also analyzed the most common terms in dissatisfied and satisfied reviews. Dissatisfied reviews contain more negative language, while satisfied reviews include words like good, great, love, and best. This shows that the review text contains meaningful sentiment signals. I also used thumbs up count to compare helpfulness across sentiment groups. Dissatisfied reviews had a slightly higher average thumbs up count than satisfied reviews, which suggests that some negative reviews may reflect problems other users also recognize. Finally, I used the review date field to look at dissatisfaction over time. This is useful because Netflix could monitor whether dissatisfaction increases after app updates or product changes. For feature engineering, I transformed the cleaned review text into numerical features using TF-IDF, which stands for Term Frequency Inverse Document Frequency. TF-IDF is useful because machine learning models cannot directly read raw text, so the text must be converted into numerical features. The model uses clean text as the main text input. It also includes structured features such as review length, thumbs up count, and the complaint theme flags. This is stronger than using only text because it combines language patterns with business-relevant signals. For modeling, I use a stratified train-test split, so the training and test sets kept a similar balance of dissatisfied and satisfied reviews. The main model is logistic regression, which is appropriate because it performs well for text classification and is more interpretable than many complex models. I also use naive Bayes as a benchmark model. I use grid search CSV with cross-validation to tune the model and make sure the results were not dependent on only one train test bit. For evaluation, I use accuracy, precision, recall, F1 score, ROC AUC, a classification report, a confusion matrix, and an ROC curve. Accuracy shows overall correctness. Precision shows how many reviews predicted as dissatisfied were actually dissatisfied. Recall shows how many truly dissatisfied reviews the model successfully captured. F1 score balances precision and recall. ROC shows how well the model separates dissatisfied and satisfied reviews across thresholds. And the logistic regression model overall performed well. It achieved about 84.7% accuracy, about 86.4% precision, about 86.3% recall, about 86.3% also F1 score, and about 91.8% ROC AUC. The confusion matrix gives the actual prediction counts. Out of the test set, the model correctly identified 366 satisfied reviews and 483 dissatisfied reviews. It incorrectly classified 76 satisfied reviews as dissatisfied and 77 dissatisfied reviews as satisfied. This means the model is fairly balanced. It catches most dissatisfied reviews while keeping false alarms at a reasonable level. From a business perspective, this is useful because Netflix would want to identify dissatisfied users early, but also avoid overwhelming product and support teams with too many incorrect alerts. The model interpretation shows which words and themes are most associated with dissatisfaction and satisfaction. Negative words and complaint-related terms help explain why the model classifies certain reviews as dissatisfied, while positive words are more associated with satisfied reviews. Based on the analysis, my first recommendation is for Netflix to prioritize app stability, especially crashes, bugs, loading problems, and playback issues. These directly interrupt the viewing experience. Second, Netflix should also create an automated NLP review routing system. Crash and bug complaints should go to engineering, login complaints to account support, payment complaints to billing teams, and UX complaints to product design teams. Third, Netflix should monitor dissatisfaction over time, especially after app updates. If the dissatisfied review rate increases after release, that should trigger further investigation. Fourth, Netflix should use helpfulness votes as a prioritization signal. If a negative review receives many thumbs up votes, it may represent a broader issue affecting more users. The main limitation is that the model predicts dissatisfaction based on ratings and review text, not actual churn. Public app reviews may also not represent all Netflix users. However, the analysis is still valuable because it turns unstructured feedback into measurable themes, model predictions, and specific product recommendations. Overall, this analysis shows how NLP and machine learning can help Netflix understand mobile app dissatisfaction, prioritize app improvements, and support better customer experience and retention decisions. Thank you.